Hi, this is Vijayanand from TriSpace Technologies. Welcome to our demo of WMR vocoder solution on Qualcomm Snapdragon APQ 8084 development kit. So we begin with our demo with running the build scripts. So this is while the code is building, let us have a look at the script file. Then we can revisit this build operations. So we are setting up the board actually in the first few commands and cleaning up all the object files and executable files. And then we're copying the build files, the necessary required C files, the C and assembly files onto the respective Android's ARM CPU core and the Hexagon DSP core. And we're building the code base for each of the individual cores using the commands for respective commands, one for the ARM and for the DSP. And then we flash all this binary onto the target board. Okay. So if you take a look at this android.min, these are the list of files, C files which have been written and optimized targeting the ARM core. As you can see, the entire list of vocoder WMR vocoder solution C code is the entire list of C code of WMR code is implemented and optimized targeting the ARM CPU. It's a mixed C and assembly ARM assembly code using ARM v7A instruction set architecture. And if you take a look at the DSP Hexagon DSP core, you see there's nothing bare minimal thing that is being built on the DSP core. Okay. So this is our build environment. Let us take a look at the build output. You see the build has been completed and the binary file WMR codec ARM has been flashed onto the board actually. Now let us run before we run the test vectors, let us take a look at the power profiler kit that we have. So we have a PPK2 power profiler kit 2 from Nordic Semiconductor, which is connected between the host laptop and the board, target board APQ 8084. So when we start this power profiler kit, it measures the current consumption of the board. Presently nothing is running on the development kit, the board. So it's an idle situation. You can see the current consumption is of the order of a few microamps. About 10 microamps is the maximum we are seeing actually. Now let us run all the entire decoder test suites. So one by one, all the test vectors are running now. The entire suite of WMR vocoder solution. And while it is running, let us see the script file contents. You see. So we're cleaning up the profiler to output file and also and we're running one by one the test vectors on the development board, and then the output file we're retrieving from the board onto the host laptop environment, which is in the folder here. Vectors QDSP6, 56, and so on and so forth. So this is the folder where all the outputs are generated. Like this, all the entire suite of test vectors, bitrate 6.6, 8.85, 12.65, 14.25, 15.85, 18.25, 19.85, 23.05, 23.85, and then DTX test vectors. The entire suite is run here. Okay, now let us take a look at the output of the decoder. So the current measurement, if let's take, now you see the peak is around about 25 microamps. So it is so our decoder solution is taking about, let's say, 30 microamps, means ideal condition of 10, for about 20 microamps it's taking. But in any case, worst case, it is less than a milliamp actually. Okay, if you round it about to milliamp also, we are if you add the decoder, and then we'll see the encoder solution also, the performance of the codec, the decoder encoder is taking out the order of 1 milliamp, which is way much better than industry benchmark figures of 10 to 11 milliamps running on most of the handsets. mobile handsets. Okay. So this is the current power profile measurements real time. In real time, it's happening. So the entire suite of decoder regression is running now. So we are almost coming to a close now. Just few more vectors to finish. And you see the current profile measurements here again. Yeah, now the entire decoder regression has finished running. Okay, so the current measurement is now it has dropped down to idle state condition, which is about 10 microamps. Now let us run the encoder regression test. Now let us see the current measurements. You see again the peak current measurements when the entire encoder script is running is about order of 20 microamps or something like that. Still within a 1 milliamp range actually. If you combine the decoder and encoder, it's rounded. We can round it to 1 milliamp kind of thing. Let us look at the encoder regression script. So this is the encoder regression script. All the vectors, encoder vectors from 6.6 bit rate to 8.85 onwards, all the way up to 23.85 and DTX text vectors. So this is the encoder solution. So this is how we're running the encoder regression. So both the decoder and encoder is completely run here. Let's see the power consumption again. You see its peak is about 25 microamps. So we are just consuming very bare minimum current consumption. Test vectors are coming to an end. 23.05 has started. While the test vectors are running and profiler is able to see, I'll just briefly tell about the configuration of the board. It's running a ARM V APQ 8084 board with a quad-core configuration of ARM CPUs and DSP cores. So we are running the targeted clock frequencies. We have not touched any of these hardware parameters or the clock frequencies on an as-is basis. This is our when we run our optimized code. This is the current measurements as seen by the profiler kit. Yeah, see now the encoder regression is completed, and you see now it has dropped down to idle current consumption, which is of the order of 10 microamps. Okay, so now let us look at the test vector outputs. We also need to ensure the test vectors are bit exact. So this is the comparison using beyond compare. So these are the test vectors that have been run just now. So if you see the timestamp, it is 18 November. As you can see, it's 11:48 started regression. And the last test vector, if you see the DTX mode, It has finished around 11:51, the encoder suite. So about 3 and 4 minutes, we have finished the entire regression suite. So this is our demo for our WMR codec showcasing the current content. We have many more such use case demos with the power measurements available to us. So if you are interested, please get in touch with us. Thank you very much for joining our demo.